My friends, good evening. The Illusion 62 was called the Flying Coffin by some pilots during the 80s, and this video won't prove them wrong. It's May 9th, 1987 in Warsaw, Poland, and we have an aircraft of this type. And it's the 62M version, slightly improved, equipped with 4 Solo-VF engines. These engines are installed in a rather special, very unique way. It's a choice that has rarely been used in aviation. The 4 engines are installed at the rear. There was another aircraft developed at the same time in the United Kingdom, the VC-10, which also uses this configuration. The VC-10 was less successful than the Illusion 62. Thank you. In any case, this design presents a risk that we'll also find, by the way, with the Concorde. The risk is that if an engine were to experience an uncontained failure, which basically means an explosion, it would start throwing parts around. Well, the adjacent engine can also get damaged. So when we look at the history of the LI-62, the VC-10, and even the Concorde, we see that this tendency to lose 2 engines at once has been widely confirmed in practice. So I was saying this plane will take 183 people on board. It almost took 184, except that 1 passenger was stopped by customs. And so the doors close, the plane lines up, it's evening, it's 10 post meridian, ready for takeoff. Destination San Francisco with a scheduled stopover in New York. It's a long flight that begins that night. The plane speeds up along the runway, takes off, switches from one controller to another, and gently starts to climb to its cruising altitude. When suddenly they receive a call, it's the radio operator who handles it. It's a cockpit with a lot of people. We have the captain, we have the usual co-pilot, we have the flight engineer, we also have the radio operator, a guy who only handles the radio. We have another guy who only does navigation. So that makes cockpits with a lot of people. There, on the radio, there's the air traffic controller who says, expedite your climb. He's insistent, climb immediately now. Why? Because quite simply, he realizes that this plane is heading toward a conflict zone, an area where a military exercise might be taking place. And he wants him to climb as quickly as possible to get above that area. With that, we have the flight engineer who, with his swivel seat, faces the controls at the central panels. He grabs the 4 engine throttles and gently pushes them forward until they show almost the same power as for takeoff. The captain pulls back on the control column, the plane pitches up, the variometer goes positive, we start to gain altitude, and suddenly the aircraft is shaken by an extraordinary explosion. What happened, and what happened very often on this plane, is that an engine exploded. The explosion starts to affect these engines, and actually it happens to many engines. Very often uncontained failures follow pretty much the same pattern. Actually, on this channel, we saw a case with a very similar explosion on, I think it was a Douglas commercial, 9 or a McDonnell Douglas 80, something like that. Actually, if you want, when you look at the engine, you have compressors that are driven by turbines that are on the other side. And how is the drive done? It's done through a shaft, so the turbines drive a shaft and this shaft drives the compressors. Simple. The problem is that this shaft is subjected to enormous mechanical and thermal stress. What happens if it breaks? Imagine the turbines through which the hot air passes, the pressurized hot air passes. Well, actually, they want to spin faster and faster, except that they have to drive compressors that compress the air. Well, that creates resistance, so these turbines have resistance that makes them reach a certain speed and stabilize there. Now, imagine that the tube breaks cleanly in the middle. What will happen to the turbines? So, this is what will happen. The turbines, since they are freed from the weight of the compressors, will speed up. And what happened in this device and in others is that literally in a tenth of a second, turbine speeds usually shown as percentages, can reach 130, 140, or 150%. So very quickly, there's the needle. In an instant, there's an explosion. And in an instant, the needle of the N2 revolutions per minute instrument will hit the stop. And actually, at that moment, the metal disc on which the blades are placed, the turbine, well, it's subjected to enormous centrifugal forces. What's it going to do? It's going to explode, it's going to burst, and then those pieces will fly off in all directions. The blades will also fly off in all directions. That's what happened that day. Reactor number 2 exploded. Naturally, it damaged reactor number 1, which is on fire. So we lost 2 reactors on the same side. Even worse, we have the fuselage of the plane being bombarded. It's being bombarded by heated metal pieces. So we have the cabin that's pierced, that's ripped open, torn in various places. The air escapes from it since it's a plane that's a little bit... It appears to be from the 1930s, though it's really from the 1960s. Well, for example, it doesn't have a mass that drops when there's a depressurization. So the air just escapes. Depressurization 30. Where are the engines located? These engines are located at the tail section, so they're in a critical area of the aircraft. Pieces of metal will start hitting the tail section, and what are they going to break? Well, one of the metal rods that moves the elevator. One detail in this plane, something quite extraordinary that's worth mentioning. They didn't have it, despite its size, they didn't have hydraulics. For the flight controls were moved by rods, ropes, cables, pulleys, counterweights, and trim tabs, and they didn't have it. There are other planes that had partial hydraulics on their flight controls, but in this case, for example, the Douglas Commercial 9, if I remember correctly, the Douglas Commercial 9 didn't have hydraulics. On the elevator, it had them on the ailerons, but not on the elevator, but the Aviation 62 goes even further. It has hydraulics for braking, but not for the flight controls. So it's something very special, but the problem is that the flight controls lacked redundancy. That means there's a part that will break, and then once it's broken, that's it. And there's no more pitch control in that plane. The pilots, when they touch the controls, they notice that in pitch, it's light. There's no response from the aircraft. They still have the pitch trim, which is controlled by 2 electric motors. That's the only thing that allows them to have any semblance of control over the plane. Immediately, they contact the air traffic controller to report the situation. And they want to return to Warsaw. So that's the first decision. We're going back, so take note of the decisions. This will play an important role, so they want to return to Warsaw. Of course, the controller tells them to turn around and all that. So they start to turn around. And then they feel that they're starting to sink. They don't know where it will stop. Will they sink all the way? Or at some point, things will settle. You should know something important. When you have a plane that is flying at its cruising altitude or almost, generally it needs all the engines that are in service. Let's take an Airbus A380. It's flying at its cruising altitude. Let's say we shut down 2 engines. What will happen? It will inevitably start to descend. It won't be able to maintain the same altitude it had with 4 engines, with only 2 running. So it will go down, down, down until it reaches denser layers of air, where this time it will be able to hold with the 2 remaining engines. It's the same if we have a Boeing 747. If it loses an engine, it won't be able to maintain the same altitude. In general, it will start to descend until it reaches an altitude where it can hold with 3 engines. So we're in a similar situation, but what pilots also do is decide to dump fuel. The problem is that the valves that allow fuel dumping are faulty. Because of the electrical problems, precisely, which were caused by that bombardment of metal parts, the valve that allows fuel dumping, sometimes it works, sometimes it doesn't. It works intermittently. Sometimes it works and fuel is dumped overboard, and sometimes it gets stuck. So that's an extremely precarious situation. They managed somehow to turn around, the plane is losing altitude. This is what they'll describe to the air traffic controller below. At some point, they realize that they might not be able to make it to Warsaw because Warsaw, at the time of the explosion, was 110 nautical miles away. So we're talking about nearly 200 kilometers. So that's huge. They won't be able to return with a plane damaged like that. So what they do is they ask the controller if there's a closer airport. There's Magdalene, there's an airport that's halfway between their bridge there and Warsaw. There's an airport, it's Magdalene. He wants to go there, yes, but there's a little problem. The controller tells them that it's a military airport. I don't mind if you go there, but I have to get permission from the military to get it. I don't have them on the radio. I have to contact them, so give me a minute. So we have an aircraft in distress, which is literally going down. And the controller, instead of giving them vectors to Magdalene, even if later on he contacts the authorities in charge of that one and coordinates with them to make sure the runway is clear and so on. Well, no, he doesn't do that. He tells them to wait and says he'll be back, repeating, yes, wait several times. Then he tries to call the Magdalene control tower on the phone to tell them, I have a plane on my hands. It's about to crash. We need to let it land. So then, meanwhile, the pilots are thinking, they're saying to themselves, is it Magdalene? That's the best option for us. Especially since, given the wind and the runway at this airport, there's a risk of landing either with a tailwind or maybe they'd have to make a big loop to come back and land. And they weren't too sure about making a big loop to land on the other side, so they were starting to have doubts. Also, the plane was heavy, so there was a good chance they'd have to land with an overweight plane. The runway isn't very long for that maneuver. It was a 3,050-meter runway, so they're thinking it might be tight, even though it could also be enough. But at that moment, they have doubts about the length of the runway. They're having this conversation while the controller is trying to get them clearance for Magdalene. At the moment, the controller tells them, okay, you're cleared for Magdalene. You can land there and then we'll help you by giving you instructions on how to get there. Well, at that moment in the cockpit, another idea starts to form in the crew's minds. And they're going to say to themselves, if we're not going to be rescued, why not go and get rescued? Especially since the plane's descent has stabilized. That means since now they're lower. And then they reach slightly denser air. And then they manage to dump a certain amount of fuel. There's a kind of stability that makes them think, why not go save them? The problem is that going to Warsaw adds 8 to 9 minutes to their flight, 8 to 9 minutes. When you have a plane with 2 engines stopped, you're down 1 from the working depth and all that. It's true that it's quite tricky then. The pilots in the end discuss it among themselves very quickly. Everyone votes to return to Warsaw. So they tell the controller to continue to Warsaw and to proceed towards Warsaw. This time, another conversation will take place with the controller. He tells them either you land directly, which means from the heading you have now. The runway will be in front of you in a few minutes and you will land straight ahead. But that will mean you'll have a bit of a tailwind. You'll be slightly in a tailwind. Or another option, if you want, it's up to you. You pass the airport, make a loop and come back to land, this time facing the wind. It's your choice. The pilots respond, okay, we'll go around, we'll arrive, we'll pass the runway, we'll enter what we call downwind, turn to base and come back on final. Once again, we can't read their minds. We're not in their position, but we can only be surprised by this maneuver that will add a few more minutes to our story. So they manage to deploy the landing gear. They begin their loop. During the loop, they can't see the runway. The controller will assist them a bit because they missed the axis during their turn, which was too wide. The controller says, you missed the instrument navigation system, I'll help you catch up. So we start giving them a bit of guidance. They are cleared to land. And then actually there was something else, something they didn't have that they hadn't realized. It's that when the metal pieces heated to over 1000 degrees were thrown in all directions, some got lodged in the cargo hold, which means there are white hot pieces of metal that were thrown and ended up inside freight suitcases. All that, what's going to happen is a fire is going to break out inside the cargo hold. The problem is that fire was probably smoldering since the engine explosion, but there was no corresponding alarm in the cockpit because probably either those alarms weren't working or the electrical power was cut or the wires were severed or something else. In any case, there was fire in the section, so under the floor where the luggage is. This fire that has been smoldering for many minutes. Well, it chose the moment when the plane was really on final approach to flare up even more. That's what happened. We won't know everything. We won't know absolutely everything about this that happened, but we know because it was recorded. We know that, for example, they lost a flight attendant. They don't know what happened to her. He searched for her on the plane, unsure what was happening to her. There are voices, screams, and one person tells another not to panic. And actually, what happened on this? Did the black box stop recording? Which means that probably the electricity stopped completely throughout the whole plane at that moment. Here's what happens. In China, while still inside of the runway, it suddenly dives toward the ground. And it's going to dive. One of the pilots realizes that it's over, that they're heading toward the ground, which is just a few hundred meters below their feet. He's going to take the radio. If he had just said it like that, it wouldn't have been known, but because the black box doesn't record, what he did was he took the radio, he shouted on the frequency, "Farewell everyone, see you soon. We are dying." The plane, a few seconds later, crashed into a forest at an extremely high speed, and it will disintegrate, killing everyone. What's terrible about this story is that in between the explosion of the engines or engine number 2, followed by the fire in number 1, there was both the tragedy and the impact against the ground. There was half an hour and roughly about 30 minutes. Subtitling, the accident happened about 30 seconds before the wheels touched down, 30 seconds before landing. It only took them 30 seconds to reach the airport, and that's why this really gives a very special weight to all the decisions that were made. That means if they had landed at Magdalene, they could have landed at Magdalene. So then, would they have landed normally, or would they have hit the plane, or would they have broken it? Or that's Mr. and Buldegum, if they had landed straight in Warsaw. By accepting a slight tailwind component, they could have touched down on the runway with that too. We don't know if it would have been a smooth landing. It would have been rough since they didn't have much control over the pitch. That's also up for debate. But the reality is that by choosing to operate this way, well, they tried to reach a runway that was too far away. The Soloviev type engines were considered better than the engines that were originally designed by the same company, by the same design bureau that imagined and developed the original Ilyushin 62. And in fact, these engines were normally, in quotes, guaranteed for 3,000 hours. The previous ones were guaranteed for 5,000 hours. That means they needed an overhaul every 3,000 hours. The reality is that the engines from the Soviet era, whether on civilian or military planes, were never very good. They might have good performance in the moment, but the problem is that the materials they were made with weren't very good, so breakdowns were quite frequent. I spoke to a technician who worked on these reactors, and he told me that. The real time. Normally, between overhauls for these reactors, it was about 800 hours, not even 3,000, it was only 800 hours. If we wanted to operate them with a certain degree of safety. By the way, the Ilyushin 62 still flies today. I believe the only company that still flies it is Air Koryo, the airline of North Korea. And I don't know how many overhauls it needs. Maybe they're overhauling it. Both flights, those are jet engines that have shown a very high tendency to break down, to explode. By the way, if you look at certain planes, we recently talked about an Antonov that became the Coyote in the United States. If you look at some Russian or Soviet planes that were successful in the West and had Western variants made, generally they don't use Russian or Soviet engines. They change the engines. They put Pratt and Whitney when it's turbines, or they put CFM when it's jet engines. But they don't use the original jet engines because that's really the weak point. Another thing about this, in Poland in the 1980s, starting from the early 1980s, there were major strike movements. The country faced social turmoil, currency collapse, inflation, and endless lines. And then there was a labor union movement that was born. It was the first union, I think, in Poland, and even in the whole world, the first union in the entire Warsaw area. And what happened is that there were a lot of strikes, and this ended up paralyzing everything. I mean, the industrial apparatus. In this situation, a company like Aldosteron, Aviation ended up with jet engines that required a lot of human labor hours because they needed to be serviced very, very, very regularly. But actually, they didn't have the people, they didn't have the money, they didn't have the resources, plus there were strikes. So it seems they received authorization to operate them beyond their limits. That means what we were doing, what very often on the Lyushins, was running reactors that had exceeded the number of hours for the overhaul. And in practice, what the officials at the time had decided was to say, since there are 4 of them, what we'll do is only 1 reactor will be over the limit. So we won't let a plane take off with several reactors over the limit. We'll only allow 1 to be over the limit. And that way, if it ever malfunctions, we can replace it, or we can bring the plane back to the country without passengers using 3 reactors. This happened often. So the problem is that sometimes Lyushin-type planes ended up with 2 or 3 engines that were actually beyond their service life. There was even a case where another Lyushin crashed. It was Flight 007 a few years earlier, in a context quite similar to the one I told you about tonight. Actually, 3 engines exceeded their potential and only 1 was new. And guess what? It was the new engine that exploded. Because often when we have this kind of object, sometimes they have manufacturing, control, or quality issues. So if you don't blow your face up after 2,000 hours, honestly, you can go up to 10,000. It'll keep working in quotes. Sometimes manufacturing issues appear early. And after that, we enter a phase where there's a plateau in terms of breakdowns. And then we start to age the reactor too much. And later we enter yet another phase where breakdowns become frequent. So I was saying that we are in 1987, and after this accident, let's say quickly, already in 1989, the Polish company stopped using its aircraft, and 2 years after this accident, it received its first Boeing 767s. Thank you, my friends, for watching this video, and I'll see you in the next one.